All right, so there's the question, Sim. Determine a region of the xy plane for which the given differential equation would have a unique solution to the point xo, yo in the region. So we're going to be looking at a differential, and this is the one I've chosen. Number 5 would be 4 minus y squared y prime equals x squared. So you're trying to find areas on the xy plane, okay? Areas on the xy plane where there are no restrictions on y. So you need to look at y and you need to look at the derivative with respect to y, given a function in the form of function of xy. So what happens when you're given a differential? If you isolate this so that the y prime is on one side, equals x squared over 4 minus y squared. See how you got this on one side? Okay, so you got dy dx equals x squared 4 minus y squared. That's the function of x and y. When you have a first order differential equation with the differential on the left, the right is going to be a function of xy. We're looking for the solution function, so we want to know where are the restrictions. So right away, can you see where there would be a restriction on y? What if y equals 2 or negative 2? That would make this thing a 0 in the denominator. That would be a restriction. That would be undefined. That's not allowed. So y is not equal to 2 or negative 2, right? That's what you want to do first. Okay? Now, let me remove this. Let me turn it over so I'm not wasting a lot of paper. Alright. So now, let's go back to our... so the first thing you want to do is get it in that form. So we have y prime equals x squared over 4 minus y squared. So we got it in this form here. So this is a function of x and y. There's no y prime over here. So it equals a function of x and y. So we want to next take the partial, you make that little thing right there, derivative of f x y with respect to y. So we got to take this right here, we got to take its derivative. I'm sorry, it doesn't equal these things anymore. Now we're trying to find the derivative of this. So how do you do that? Well, this is a kind of difficult partial derivative calculus problem, right? So, and you find a lot of differentials are hard calculus problems. You use calculus left and right in differentials. So how do I take the partial derivative with respect to y? Well, first of all, x is not considered a variable if we're taking it with respect to y. So let's look at what we have here. X squared 4 minus y squared. So this is basically a constant. This is a constant. This is our only variable that we're concerned with right here. So let's do the chain rule. You can do the chain rule if this is a constant. Doesn't matter. So we got x squared derivative times the bottom 4 minus y squared plus, or minus actually, I'm sorry, minus the derivative of this times the derivative of this, right? Over the denominator squared, right? The derivative of the first, that's the derivative of the first times the 1 in the denominator, minus the numerator times the derivative of the denominator over the denominator squared. Right? So what's the derivative of a constant? This is the same as like 8 or 2. The derivative of a constant is 0. So it's going to be 0 times 4 minus y squared minus x squared. What's the derivative of this? Negative 2y. Negative 2y. That's 0. That's negative. Drop the 2. That's negative 2y. Over 4 minus y squared squared. Are you following along there? What's this? This is 0. What's this? These become pluses. So you got x squared 2y over 4 minus y squared squared. And this is partial f, partial y. You see that? Now what do you notice? Are there any restrictions here? Can y equal 0? Sure, why not? So basically you have the same restriction. Y can't equal 2 or negative 2. So let's draw out 2. There's y equals 2. Put a dashed line there. There's y. Here's x. Here's negative 2. Dashed line. So y can equal all this, and all this. It just can't equal along these lines here. So any x value that gives a y value, y can't equal these along these lines. So that's the region. And I'll probably do a few more of these type of problems. That's the region XO, YO can exist. XO, YO being a value where a unique solution passes. So it could exist right here. That would be an XO, YO where a unique solution passes through. All of those areas, all that area is eligible to contain solution lines through those points.